Hey everyone, and welcome. Today, we're going to solve a really common and kind of frustrating problem. How do you get an AI to know about your stuff? You know, your reports, your documents, your notes. Let's dive right in and figure this out.
So you've probably run into this, right? You've got this super powerful AI, maybe something like Llama 3, but you ask it about a company doc you just wrote and nothing. It's totally clueless. And that's because these standard AIs, they're trained on this massive but frozen in time set of data. They have no way of knowing what happened yesterday, and they definitely can't see your private files.
So what's the fix? Well, the absolute best way to think about it is with this analogy, the open book exam. A standard AI is like a student in a closed book test. It only knows what it's already memorized. But with this technique we're talking about today, called RAG, we're basically giving the AI an open book. It can look up the facts in your documents before it says a word. This is huge, because it means it can use brand new info, and this is the big one, it's way less likely to just make stuff up.
And that brings us to the star of the show today. This whole open book method has a name, and it's RAG. So let's get a proper definition up. RAG stands for Retrieval Augmented Generation. Yeah, it's a bit of a mouthful, but the idea is actually super simple. We retrieve some relevant info from one of our documents, and then we augment the AI's prompt with that info before it generates an answer. We're essentially giving the AI a custom, just-in-time cheat sheet for every single question we ask it.
Okay, so we know what RAG is, but how does it actually work? You know, what's happening under the hood that takes our question and magically finds the right page in that textbook?
It really just boils down to these 3 steps. First, you ask a question. Immediately, a little component we'll call the librarian, its technical name is a retriever, scans all your documents to find the most relevant little bits of text. Second, to do that, it has to translate your words and documents into numbers. This is the magic part, and it uses something called vector embeddings. And finally, it grabs the info it found and stuffs it right into the AI's prompt. Let's just double-click on that translate step for a second, because this is where things get really cool. How on earth does a computer know that delicious pizza and tasty pie are talking about the same thing? It uses vector embeddings. It turns a piece of text into a long list of numbers, a vector, in a way that actually captures its meaning.
And this example just nails it. In this weird mathematical space, the numbers for puppy are going to be really close to the numbers for dog, but both of them are going to be miles away from the numbers for car. This is what lets our librarians search for meaning and concepts, not just exact keywords. It's incredibly powerful.
All right, enough theory. Let's get our hands dirty. How do we actually build this thing? We're going to use an amazing Python toolkit. The 2 main players here are LangChain, which is a framework for connecting all these AI pieces, and Llama, which lets us run these powerful models right on our own machine.
Before we jump into the code, here's a quick checklist. You're going to need a Llama installed and running. Then you'll want to pull 2 models. Llama 3 is going to be our main brain, the part that actually writes the answers. And then a special model, Nomic Embed Text, is going to be our translator, the one that creates those embeddings. After that, just a quick pip install for these 4 Python libraries you see here.
Okay, let's pull up the script and see how all these concepts actually turn into working code. We're going to build what's called a RAG chain, basically connecting all the parts we've been talking about step by step.
First things first, we need a textbook for our AI to read, so we'll just create a simple text file with some secret info that the AI couldn't possibly know. Then we use a text loader to load that file, and this part's important, we use something called a recursive character text splitter to break it up into smaller chunks. We do this because you can't just feed a whole book to an AI at once. Smaller focused chunks work way better.
Now for that translation part. And with LangChain, this is unbelievably easy. Look, with just 2 lines of code, we're building our entire library. First, we tell it we want to use Llama embeddings with our special Nomic Embed Text model. Then we just tell Chroma, our vector database, to take all our text chunks, use that embedding model on every single one, and store the results.
And boom, just like that, this vector store object we created is our library. It's our digital textbook, all indexed and ready to be searched by meaning.
So we have a library, now we need a librarian. And again, this is almost laughably simple. We just take our vector store and call the .asRetriever method on it. That's it. Seriously. And there you have it. That one little line of code just gave us our automated librarian ready and waiting to find the most relevant facts for any question we throw at it.
All right, last part. Let's assemble the whole machine. First, we fire up our main AI brain, Llama 3.
Next, and this is absolutely crucial, we create a prompt template. This is basically a set of instructions that says, hey AI, I'm about to give you a user's question and some context. You have to answer the question using only the context I provided. Finally, we just pipe all of these things together into a single runnable RAG chain.
And with that, the system is built. The code is ready. So now for the moment of truth. Does it actually work? Can our AI really access that secret information we hid away in our little text file?
So, we're going to ask it a very specific question, something it has zero chance of knowing from its general training. What is the secret code to the bunker? The answer only exists in that one file we created.
And check it out. The AI comes back with the perfect answer. The secret code to the underground bunker is Blue Bananas 99. It worked. The chain found the right piece of text, passed it to Llama 3, and got us a precise, factual answer. Amazing.
You know, this technology is way more than just a neat party trick. It is a complete game changer. You can now turn a general-purpose AI into a specialized expert on literally anything, your company's support documents, your personal research, you name it. So that just leaves one final, very exciting question. Now that you can give an AI its own personal library on any subject in the world, what are you going to teach it first?